All right, today we're diving into a really brilliant piece of engineering from the early days of microprocessors. We're talking about the Intel 8085. We're going to pull back the curtain on this one clever trick it used to solve a huge problem, a trick that honestly helped make computing accessible to way more people. But before we get into the nuts and bolts, let me ask you this. Imagine you've got one single train track. And on that track, you need to run a super fast passenger train and a slow, heavy cargo train. How do you make sure they don't smash into each other? How does each one know when it's their turn? Keep that image in your head because that's the exact kind of puzzle early chip designers were trying to solve. So that brings us to our first big topic, the microprocessor pin problem. And that subtitle says it all, fitting a highway of information onto a tiny chip. Seriously, think about it. You're trying to build this massive, complex highway system, but your entire workspace is the size of a fingernail. That was the reality in the 1970s. You see, every single time a microprocessor needs to talk to the outside world, whether it's memory or your keyboard or anything else, it needs a physical connection, a pin. And back then, pins were like beachfront property. They were incredibly valuable, and there just weren't enough of them to go around. The more pins you added, the bigger and more expensive your chip got. So you end up with this massive tug of war, right? On one side, the CPU is screaming for more connections. It needs a whole set of wires, a bus, just to send out addresses for memory, kind of like street addresses for your data. And then it needs a completely separate bus to actually move that data back and forth. But on the other side, you've got the hard facts of physics and economics pushing back, saying nope, fewer pins means a smaller chip, and a smaller chip is a cheaper chip. So what gives? Well, this is where the genius comes in. Instead of trying to add more pins, Intel's engineers came up with this brilliant, almost deceptively simple solution called multiplexing. And the whole idea? Make one bus do two jobs. So what is a multiplexed bus, really? It's exactly what it sounds like. You take one single set of physical wires, and you just make them work twice as hard. For a little bit of time, they carry one kind of information, and a moment later, they carry something completely different. It's our train track analogy all over again. You just need a bulletproof schedule to make sure the passenger train and the cargo train don't end up in the same place at the same time. And this is exactly how the Intel 8085 pulled it off. It had these 8 shared lines. You'll see them called AD7 down to AD0, and they were the workhorses. One tiny fraction of a second, these 8 wires are carrying part of a memory address. And then, blink, the next fraction of a second, those same 8 wires are being used to carry the actual data. So cool. One set of pins doing 2 totally different critical jobs. Okay, but wait a minute. If these wires are switching jobs so fast, how does anything else in